cell phone. You see it? Hey guys, it's Miss B again. Just a couple of notes. We had a big meeting yesterday morning, and decision was, or what we were told is that there will be a learning packet for you all to pick up either online or through the school's Google Classroom or at the school on Wednesday from, I think it's 10:30 to noon when they do the food pickup as well. That packet will have a calendar for what assignments go with what days, and it will have assignments from all 4 of your course plus electives. So it's kind of a packet to cover you for the rest of the school year. I'm going to finish out the videos for this week. My office hours are still going to be 9 to noon every day. Because of what's going on with things at school, my Monday office hours have to be the same as everything else. So my office hours are 9 to noon, Monday through Friday. If you need me any other time, just email me. It's not a biggie. I'll help you out as I can. You know, the packet is a lot of review stuff, some enrichment stuff, just a way to get you through the rest of the school year. So good luck with that. And today what we're going to do, this is the Algebra 1 video. So today what we're going to do is we're going to work with finding square roots and cube roots of numbers that include variables. So we have numbers that are not perfect squares, and then we have variables under our radical. So that's going to be kind of a different challenge. But the procedure we established yesterday or day before yesterday is the exact same procedure we're going to use today. So let's get started with this. Now, these notes are in the Google Classroom for our class. They're all part of the same thing. It says week of March. It's like it says Algebra 1 week of March 3rd or something like that. And all of these are in here. There's some other stuff you can do. If you've got questions on how to do it, it's after we get finished with this, it's all review stuff. So, you know, just do the best you can. Keep yourself focused. If you need me, holler. I don't mind, okay? So let's look at this. It says, if I have the square root of some number to a power, some variable to a power, if this power is an even number, when we take the square root of it, it's just the variable, and then you divide the square root by, or that radical, that exponent, sorry guys, it's been one of those mornings, you divide that exponent by 2. So if it's the square root of a to the 8th, your answer is a to the 4th, because we're taking out matching pairs, and there are 4 pairs of a's that you can take out. If it's not an even number, then you're going to have 1 under the radical, and you just subtract 1 from whatever the exponent is and take that number and divide by 2. So if we're looking at this and we're doing this the way we always have, x squared, so I got the square root of x squared, which is x times x. So here is my pair on the inside, so they become 1 on the outside. But if I have a number and a variable, still don't change my process. First thing I'm going to do is my factor tree. 9 is 3 times 3. K to the 10th, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Ks. I'm looking for groups of 2. There's one group of 2, and another, and another, and another, and another, and another. So now, when I simplify this, when I write it in simplest terms, I have 3, and I have 5K, so that's K to the 5th. So if I'm looking at number 4, and it's 14A to the 19th, do I really want to write out 19 A's? No. 40 is 2 times 20, which is 2 times 10, which is 2 times 5. So I've got that set of 2's. But then there's nothing that I can do with those because those are singles. So the next thing I'm going to look at is my a to the 19th. Well, a to the 19th is a to the 18th times a. And the square root of a to the 18th times a, you take that 18, divide by 2, that becomes a to the 9th. And then what I have left is 2 times 5 in my square root, and that a right there in my square root. So as strange as that looks, that's what it is. We break it apart piece by piece. And because we're working with square roots, we're looking for sets of 2 of matching pairs. So if I'm looking at p to the 15th, q to the 9th, r, and I'm looking at the square root of that, I'm going to do this the long way because I've got some space. I have 15 p's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 9 q's. 1, 2, 3, 4, 5, 6, 7, 8, 9, and an R. Okay, those are the pieces I have. When I start pulling pairs, I've got 1, 2, 3, 4, 5, 6, 7 pairs of P's. One, 2, 3, 4 pairs of Q's, and no pairs of R's. So anything that I didn't circle in finding my pairs becomes something that stays under the radical. So I have a P, a Q, and an R left. So what I want you to do is I want you to take 3 minutes. And I'm just going to leave them up here, and on your own paper, I want you to try 8 and 10. So you've got 3 minutes. Okay, guys, let's look at these. First one, the square root of 27 into the third. Do our factor tree of 27. 27 is 3 times 9, which is 3 times 3. And then we have into the third. So now let's go through and circle our pairs. I have a pair of 3s and a pair of n's. And then I write down everything I didn't circle. Okay. On number 10, the challenge was we already had a number in front. So now we have -2 times whatever we come up with. So let's do 180. Factor tree first. 180 is 2 times 90, which is 2 times 45, which is 5 times 9, which is 3 times 3. Then I have u squared and v. And I'm taking the square root of all of that, so I'm looking for matching pairs of factors. I write down my -2 I already have on the outside. I have a pair of 2s. I have a pair of 3s. And I have a pair of u's. Then that is, everything else goes under the square root. So I have a 5 and a v. So my final answer is -2 times 2 is 4 times 3 is, or sorry, -2 times 2 is -4. -4 times 3 is -12u times the square root of 5v. Now, we've always done this. These are square roots, and now how do we move that to cubed roots? Same thing we did the other day. We take what we have, and instead of looking at pairs of 2, we're looking for sets of 3. Now, if we're doing a cubed root, and that exponent is a multiple of 3, our answer is just our variable to a power divided by 3. If it's not a multiple of 3, then we're looking at pulling out sets of 3s and leaving behind what doesn't get used. So if I look at number 13, it says I want the third root, the cubed root of p to the 7th. So let's look at this. I have, oops, I was looking at the wrong one. Let's try with number 13 again here instead of 15. The cubed root of x cubed. Well, x cubed is x times x times x. Well, there's my 3 x's. So 3 on the inside when I'm talking about a cube root is 1 on the outside. Not too terribly painful. So let's look at how it happens when we have a combination. We've got a coefficient and a variable and an exponent, all under a cube root. So let's see what that does for us. So now we have 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. A lot of 2's there. And then I have m to the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, 9 m's. I'm looking for sets of 3 matching factors. So there's one set of 2's and another set of 2's, and then 1, 2, 3 sets of m's. So my final answer is 4m to the 3rd. Okay? So we just take it in little pieces. Like if I'm looking at number 15, this is the cubed root of p to the 7th. So I have 1, 2, 3, 4, 5, 6, 7 p's. I'm looking for groups of 3 because it's a cubed root. So there is 3 p's here, and 3 p's here. And then there is 1 p that gets left under the cubed root. So my final answer here would be p squared times the cubed root of p. Now, I want you to take a minute and I want you to try 17 and 19. Actually, I'm going to give you 3 minutes to try 17 and 19. Okay? All right, so let's look at 17 and 19. On 17, the first problem is that is a big old number. So I'm going to slide over here to the side where I have a little more space. And I'm going to do my factor tree for 512. 512 is an even number, so it can be divided by 2. That's 2, it's 21. Wait a minute, no. 2 goes into 5 twice with 1 left over. 2 goes into 11 5 times with 1 left. Okay, 256. All right. Divide by 2 again. 128. Divide by 2 again. 64. Divide by 2 is 32. Divide by 2 is 16. Divide by 2 is 8. Divide by 2 is 4. Divide by 2 is 2 times 2. All right. And then I have x and y to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm looking for groups of 3 like factors, 3 like terms, 3 pieces that are exactly the same, so I can take 3 from the inside and put 1 on the outside. So there's 1 set of 3 and another set of 3 and another set of 3. Now the x isn't going anywhere because it's a solo guy. And I've got 1, 2, 3 sets of y's. Now, do I have anything left over? Look and see. I used all my 2's. I didn't use an x, and I didn't use a y. So my final answer is 2 times 2 is 4 times 2 is 8. So my final answer is 8y to the 3rd times the cube root of x, y. So now the difficult, no problem, just a little tedious in terms of how much I had to pull out and how big that factor tree was for my first number. So let's look at number 19. This time, my issue is a little different because I have a negative number under my cubed root. But remember, like we talked about in the other lesson, if it's a negative number under a cubed root, it's okay. Because a negative times a negative times a negative times a negative ends up with a negative, so you're okay. So now let's look at this. Negative 32. That's negative 2 times 16. Okay? And then that's negative 2 times negative 8. And that's negative 2 times 4. And then that becomes negative 2 times negative 2. P to the 17th. I am not writing out 17 P's. But I got to think about what's the closest multiple of 17, closest multiple of 3 to 17. Well, that's 3, 6, 9, 12, 15. Okay. So I'm going to rewrite this as P to the 15 divided by 3 plus 2. It's 15 plus 2 gives me what I want. And then I have Q to the 8th. Well, that would be Q to the 6th. Let me rewrite this again because that just doesn't make, there's a better way to do that. So I've got P to the 15th, P squared, because 15 and 2 is 17. Then I have Q to the 6th and Q squared. Okay, so now let's see. There's one group of 3. But that's only a group of 2, so that's not going anywhere. Okay, now here, 15 is a multiple of 3. 15 divided by 3 is 5. So P to the 5th pulls out. P squared stays behind. 6 is a multiple of 3. 6 divided by 3 is 2. So Q squared comes out and a Q squared stays behind. So my final answer is negative 2 P to the 5th Q squared times the cubed root of negative 2 times negative 2 times P squared times Q squared. Now I can clean that up a little bit. And I can rewrite this as negative 2 P to the 5th Q to the 3rd times the cubed root. Negative 2 times 2 is 4. P squared Q squared. So taking the square roots and the cubed roots of more involved numbers, things that involve both a number and a series of variables, is a matter of remembering to do your factor trees and look for either sets of 2 or sets of 3. I hope this was helpful. Just as a reminder, the videos will go up in just a little bit. Mrs. B teaches me. Keep looking there. After I finish this series of getting, teaching this last skill, then I'm going to go back and I'm going to start reviewing stuff we've done for the rest of the year. So they'll be there as a reference for you. Stay safe. Be good. And if you need me, call me or email me. All right. Bye, guys.